am here to share a similar topic, a DT-based idea about the partial differential equation. How the partial differential equation applicable in engineering, especially in EEE. At the basics, look at partial differential equation. EEE is nothing. The partial differential equation states the amount of change in space with respective time, and the EEE is fully based on the time and the change in the flux of the electricity. At the very beginning, we can see the partial differential equations are essential in electrical and electronics engineering, serving as a crucial mathematics tools. This partial differential equations plays a main role in circuit analysis, electromagnetic induction, signal propagation, and she will tell the fundamental of PDEs.
So I am Shruti from PDE department, and then I am going to explain about the definition and types of partial derivatives. First of all, definition is use functions with many variables. There are three types. First one is symmetry. There are three types: elliptic, parabolic, and hyperbolic, and each one represents each physical situations. Like this is heat, and this is wave, and this is fluids. And then the mathematical representation of PDEs. Is equal to is equal to 0. So it is a mathematical representation. And then there are three types to solve that PDE. First one is separation of variable. Second one is method of characteristics, and numerical methods like computer.
Partial differential equations in circuit analysis. At the basic, circuit analysis plays an important role in electrical department. To find the normal circuit, we use the ordinary differential equation. For a high frequency circuits, we use a partial differential equation. At the beginning, a transistor analysis. This explains the on and offing of the switch, how prolonged period it can on or off, and the electromagnetic field theory. The Maxwell's law is fully based on the electrical, the change in field and the change in electrical, and the Ampere's Maxwell's law. This PDE are directly proportional to the electromagnetic field theory, and the signal motion, how the waves forms in the sine cosine waves.
So the electromagnetic application overview. First one is wave equation. PDE solve the electromagnetic wave equations, and it is used in antennas and designs like that. Next, heat transfer problem. This model heat flow in electrical systems and helps in thermal management, keeps circuit and devices cool, and electrostatic and magnetic problems. Laplace equation to solve PDE, and then it is essential for our department schedule.
Future trends in electrical engineering. Machine learning integration plays an important role in PDEs. The combination of partial differential equation and machine learning became a powerful tool in electrical engineering. And multi-scale modeling. Electrical and electronic systems often involve process happening in multi-scale modeling. And the real-time application. The partial differential equation has a huge development in future trend. It combined with the EEE, IoT, AI-based system to grow an advanced electrical future.
So the methods in engineering to solve PDE. First one is finite element method, and then finite difference method. Finite element method convert PDE into algebraic expressions, useful for solving complex shapes like that. The example, bridge and machine. Finite difference method approximate PDE by breaking them into small steps.
So, as they said, partial differential equations are useful in various areas. So differential equations, as he knows very well, differential equations are used in our day-to-day life, in everywhere, wherever we come across, okay, rate of change. So even as you are telling, elliptic, parabolic, hyperbolic, these are all the various types of areas where you can use differential equations in the sense of partial differential equations, because heat transfer, for heat transfer, multiple independent variables may be used, because heat transfer happens with respect to various scenarios, various situations. Again, waveform. So wave and transfer of waves. So like signals. So signal is a waveform. So transfer of signal happens because you transfer it from a place and it gets received from one end. In between, various noise, various other things gets mixed. So in the receiver end, you want to clearly hear what is the real wordings or what is the voice is sent to you. You should provide some noise filters. In that again we come across the concept of differential equations. Similarly, fluid flows. I was telling you like that water flow, like any kind of flow, pipelines, this from various areas, this crude oil transfer is happening. So from the one place to one place, various water movements, fluid movements, all happening. So in that, if there is any kind of factors affecting that, we can understand the rate of change of fluid from one place to another place can be analyzed using partial differential equations. So that is what they want to tell today in various areas how partial differential equations are useful. So you have understood not only in one scenario, it is useful in various areas. Thank you.